Howdy, the topic of my literature review is Occlusion Aware on UAV. This review explores how UAVs can overcome occlusion problems when conducting outdoor surveillance. UAVs, when flying over outdoor environments, often encounter situations where buildings or structures block parts of visual field. Recognizing and handling these occlusions is a crucial factor for effective reconnaissance and surveillance operations. Occlusion handling is essential for maintaining reliable coverage passes and achieving robust real-time observation. In today's presentation, I'll first describe my literature search process and then classify and compare the selected papers. I conducted a structured literature search. Initially, 67 papers from Google Scholar were identified. After removing duplicate irrelevant papers and filtering out occlusion detection-only studies, 11 papers were selected for reviews. I classified these papers into three main groups. Group 1 focused on intelligent transportation systems, mainly addressing vehicle detection and tracking under occlusion using AI techniques. Group 2 focus on multi-view and dynamic object occlusion-aware approaches, using multiple cameras and feature-based tracking to handle occlusion in moving objects. Finally, Group 3 deals with UAV coverage path planning, proposing strategies to optimize UAV flight paths or viewpoints while minimizing occlusion over occlusion environments. Group 1 mainly use CNN-based classification and lightweight models to improve detection even under occlusions. These methods are efficient and enable real-time processing, but their major limitation is that they are focused only on static vehicle environments and don't address more dynamic or complex occlusion cases. Still, they offer valuable insights for lightweight occlusion-aware design in urban UAV surveillance. Group 2 explores occlusion-aware approaches using multi-camera systems to track multiple targets even under partial occlusions. These studies also focus on tracking moving objects under dynamic occlusion using feature-based methods and propose collaborative perception frameworks among connected vehicles to maintain occlusion-free sensing. These approaches are valuable because they move beyond static setting and try to manage dynamic occlusions. However, maintaining high detection accuracy in highly dynamic environment remains a significant challenge. Still, these studies provide important insights for my future research that needs to handle dynamic occlusion from multiple perspectives. Group 3 focus on UAV path planning strategies that incorporate occlusion aware to optimize aerial surveillance. Different flight patterns, such as spiral, zigzag, and alternating passes, have been explored to minimize occlude areas during UAV missions. Waypoint generation methods have been also proposed to maximize visual coverage under occlusion constraints. Geometric approaches based on polyhedral models have been introduced to calculate occlusion-free viewpoints, providing a theoretical foundation for UAV observation path plannings. While these strategies offer important planning techniques, they typically assume static environments and simplified obstacle models, highlighting the need for more adaptable real-time occlusion handling in dynamic and complex urban systems. From reviewing this paper, it is clear that single UAV systems struggle with dynamic occlusions. Collaborative perception strategies such as multi-agent system and multi-view fusion shows the greatest promise for achieving robust occlusion aware. In summary, we see that the single UAV system struggle with dynamic occlusion while multi-view and collaborative methods significantly enhance robust. However, most current approaches still assume static environments, limiting real-time applications.